Solar panels have this wild paradox at their core. They absolutely need the sun to work, right? But at the same time, the sun's intense heat can be their own worst enemy, seriously hurting their performance.
So what if we could tackle that weakness head-on? We're going to dive into a new study that does exactly that, with a super elegant solution that could make solar power way more efficient. Okay, so the heart of the problem has a name. It's called thermal efficiency loss. It's a fancy term for a really simple idea. The hotter a solar panel gets, the worse it is at doing its job. Turning sunlight into electricity. Heat is basically the villain of our story today.
And trust me, this is not a small problem. The research is super clear on this. For every single degree Celsius a panel heats up, its efficiency drops by about 0.5%. Now that might not sound like a lot, but just imagine a huge solar farm on a scorching hot day. Those little 0.5% add up fast.
So it's a hot problem, literally. How have we tried to fix this in the past?
Well, one of the first really clever ideas was to just move solar farms onto water. They're called floating photovoltaics, or FPVs. And this was brilliant, really. It solved two problems at once. First, it saved a ton of land space. And second, the water itself acts like a giant natural coolant. Pretty smart.
But of course, we wanted to do even better. So engineers developed active systems, like spraying a fine mist of water over the panels, or pumping cool water through channels behind them. And yeah, they worked, but there was a huge catch. They all need pumps. And what do pumps need? Electricity. The very thing the solar panel is trying to make. It's like taking one step forward and half a step back.
And this is where this brand new study comes in. It offers an incredible 2-for-1 solution that completely sidesteps that whole energy problem.
So meet the Natural Convection Cooling Loop, or NCLC for short. The most incredible thing about this device is that it's completely passive. We're talking no pumps, no motors, no electricity needed. It just works.
The genius here is that it does two jobs at the same time. First, it's a radiation filter, so it stops some of that heat-generating light from even hitting the panel in the first place. And second, it's a passive cooler, constantly pulling existing heat away. So it's basically a shield and a heat sink, all in one.
Okay, so you're probably wondering, how on earth does this 2-in-1 pump-free system actually pull this off? Let's get into it.
Let's start with that first job, the radiation filtering. The easiest way to wrap your head around it is to just think of it as a pair of high-tech sunglasses for the solar panel. This graph here shows what's really going on. The device has a thin layer of water that is fantastic at absorbing infrared light. That's the part of sunlight that solar cells can't use anyway. It just creates wasted heat. But it lets all the good light, the stuff that actually makes electricity, pass right on through. So it's literally filtering out the bad stuff and letting in the good.
Now for its second trick, that incredible cooling loop. This thing is like a silent, self-powering engine. It's so cool. As the water over the panel absorbs heat, it gets a little warmer, becomes less dense, and naturally starts to rise. This movement pushes cooler, denser water down from a reservoir. That cool water then flows over the panel, heats up, rises, and the cycle just keeps going, constantly pulling heat away. It's all driven by pure physics. No pumps, no power, nothing.
So the design is just brilliant, right? But does it actually work in the real world? Let's take a look at the results.
The answer is a huge yes. The study found that this NCCL system lowered the panel's average daily temperature by a massive 15 degrees Celsius. That's a really, really big drop.
And hey, remember that 0.5% rule we talked about? Well, a 15-degree temperature drop translates directly into a 3% increase in electrical efficiency. That's 3% more clean energy every single day for free.
This chart really puts it into perspective. A typical floating panel is running at about 48 degrees Celsius. With this new cooler, it drops all the way down to 33. I mean, that's just a game-changing difference.
Now, I know what you might be thinking. Okay, a 3% gain. Is that really a big deal? But when we zoom out and look at the big picture, it becomes crystal clear why this matters so much.
One of the most important findings is that this system is incredibly tough and reliable. Simulations showed it works like a charm under the intense summer sun, but it still provides a cooling benefit even on a low-light winter day. That makes it a practical, year-round solution for pretty much anywhere in the world.
So what this all adds up to is pretty amazing. You get more electricity from every single panel. By keeping them cooler, you're also extending how long they last. You're still getting the land-saving benefits of floating solar, and this is the real kicker, It does all of this without using a single watt of extra energy. You know what this research really shows is that sometimes the most powerful solutions aren't the most complicated ones. It's about cleverly using simple physics. This tech makes solar panels cooler, more efficient, and just plain smarter. It really makes you wonder, right? What other simple, brilliant ideas like this are just waiting out there to be discovered, ready to power our future? Thanks for joining me.